Alright, in this video we're going to be looking at arcs and how they're measured angle-wise. So first let's talk about what an arc is. An arc is just a connected section of the circumference of a circle. A circumference, or the circumference of a circle, you can think of almost being equivalent to the perimeter of a circle. The circumference is the distance that you would travel if you walked all the way around the outside of the circle. So again, circumference is the length of the path along the outside of the circle. You may even remember calculating this in grades past. But an arc is just a section of this, let's say between that point and that point there. The part of the circumference that is the part of the circle in between that would be called an arc. So that's arc, A-R-C. So it's a connected section of the circumference of a circle, and we have two ways of measuring this. We can measure arcs in degrees, that is, how many degrees of arc is this, or we can measure it as a distance, how far is it from here to here along that path. Later on I'm going to show you how to measure that in terms of distance, but right now we're going to measure it in terms of degrees. Now, if you'll remember, or if you've never known, a circle, all the way around a circle, is 360 degrees. So if you're not aware of that fact, make sure that you remember that very, very well, is that if you have a circle, it has 360 degrees of angle. If you think 180 degrees is a straight line, so imagine doing that twice and you'll come right back to where you started. So all the way around a circle is 360 degrees. And when we take the degree measure of an arc, basically what we're doing is we're saying what fraction of those 360 degrees are we using. Say, are we using 50 degrees of those 360 degrees? And so that's how we're going to be measuring arcs for the first part of this objective. So let's take a look at this. Suppose we have an arc, and I'm going to just create an arc that looks about like this. We'll say it goes from here to here. So we have this arc right there, and I'll try and make that dark enough and wide enough that you can tell what part of the circle I'm talking about. So this arc that runs between point A and point B. It was bugging me, so I know it was bugging some of you. Alright, so this arc is from A to B. The way we write that is we say that this is arc AB. It's named by its endpoints, just like a segment. But now we're going to put a little arc over top of that. And so that now means the measure of AB. And the way we're going to measure this at first is from what's called a central angle. And a central angle is what results if you make an angle whose vertex is the center of the circle. Here and here. So now we can see we have this angle, and I'll name this point C. So I can say that angle ACB is an angle with its vertex at the center of the circle, and we call that a central angle. Now this central angle, if we think of this as rays that continue outward infinitely, that central angle cuts its way through this arc. So it cuts this circle into arc AB. We say this is the intercepted arc. So this central angle intercepts arc AB. And when we have this situation, we have something that's very, very, very nice to look at. If you have a central angle, the measure of the arc that it intercepts is exactly the same as that central angle. So when I drew this angle to be 60 degrees, which means the measure of this arc is also 60 degrees. And I would write that by saying the measure of arc AB is 60 degrees as well. So if you have a central angle, the measure of the arc in degrees is just going to be equal to that central angle. So you can see there's this really nice connection between these arcs and the angles that are involved as well. Alright, so what we're going to look at now is how to get the degree measure of an arc from all kinds of angles inside a circle. And we've already looked at one situation, and we have 3 more. So there are 4 total situations we're going to look at. We're going to look at how to find the measure of the arc from a central angle. We're going to find the measure of the arc if the vertex of the angle, instead of on the center, is on the edge of the circle. Then we're going to see what happens if the vertex is somewhere on the interior and then somewhere on the exterior. So let's start with what happens if the vertex is on the circle. So for this situation, I'm going to create an angle where the vertex of that angle is on the circle itself, something like that. And we will call these points A, B, and C just to have something to call them. And I'm just guesstimating here. Let's say angle ABC is about 40 degrees. The arc that's intercepted by this angle, which would be arc AC, which I will kind of breezily sketch here just to make it more obvious. So arc AC, the measure of that is going to be twice this angle. And these angles are called inscribed angles. So an inscribed angle is an angle whose vertex is on the circle, and we generally stop it right here where it intercepts the arc. And again, when you have this situation for an inscribed angle, the measure of the arc, so the measure of arc AC is going to be twice the angle. So in this case, the measure of arc AC would be 80 degrees. Our next situation considers what happens when we have 2 chords or 2 secants, but we're really just interested in the parts that are chords. But what happens when they intersect on the inside of the circle? So we have now 2 angles formed that intersect arcs, or intercept arcs rather. So we have arc AB, and then we have arc CD. And when we have this type of situation and we're looking to determine either the measure of these arcs or the measure of these angles, which, by the way, let's go ahead and point out that these angles will be congruent because they're vertical angles. But if we want to know either the measure of the arcs or the measure of the angles, the way we can do this is by knowing that if I take whatever one of these angles is and I multiply it by 2, that's the same as the measure of the sum of these arcs. For instance, if my angle is, I don't know, say 60 degrees, then the sum of these 2 arcs would be twice that. So the sum of this arc plus this arc would be 120 degrees. For instance, that could arrange itself in any way. Let's suppose this arc, the measure of arc CD, was 40 degrees. Since we know that the sum of these 2 has to be 120, twice that, then the measure of arc AB would have to be 80 degrees, because this one and this one, this arc and this arc, their measures have to add up to twice the measure of the angle on the inside. And so that's what happens if we have 2 chords or 2 secants that intersect on the inside of the circle and not at the center. If we have the center, we can just use our formulation for when we have a central angle. Alright, final situation is what happens when we have secants or tangents that meet in the exterior of the circle. So let's draw a secant line, so that intersects twice, and a tangent line, which intersects once. And I'll name off some points here so that we have some references. All right, this actually intercepts two arcs. We have one that is arc CB, and then we have one that is arc DB. So DB is this arc here, and that's intercepted by this angle. CB is also intercepted by this angle, so it intercepts two of them. And when this happens, when the vertex of the angle is outside, if you take twice the measure of the angle, it's equal to the difference of the arcs. So if I take the measure of this arc minus the measure of this arc, then that is going to be twice this angle, and you'll work some calculation problems with that a little bit later.